Hey, Jasmine. Here everybody comes. It's great to see you all today. How are you all doing? One thumb up, two thumbs up? Good, wonderful. That's what I like to see. One thumb up for Sophie. Excellent. All right. Anybody have any questions before we dig right into our lesson for today? All right. So far, most of you are doing really well, keeping up with the due dates, understanding the assignments. If there's anything that you need a little more help with, please don't wait too long to ask and don't allow yourself to fall behind. All right. Hold on a second. Yep, that's fine. Just make sure you turn it on at some point in the class here. All right. All right, let me go ahead and share my screen with you and we will begin today's class. Let me know if you cannot see that where it says Earth Science. Let me turn this on here. All right, takes me just a minute to arrange the screen. All right, there we go. Okay, so we are going to talk a little bit today about longitude and latitude. Before we do though, these first couple classes, we always have to get some just information out of the way. So a couple things that I want to talk about today. Number one is the supplies list. So most of the supplies that are listed in your lessons, in the supplies needed, are ones that you will use in your daily classes, not the live ones. You don't need to bring those to class. Sometimes though, there will be some that you need to bring to class. And hopefully I have made that pretty clear for you to be able to see. So I'm going to show you what I mean here. This is, if you click here where it says classroom resources, there should be a projects information. And then if you click here where it says modules, if you look at the beginning of each of these, it'll say supplies needed this week. And then number two, supplies needed for chapter 2 and a required project. This one here, supplies needed for chapter 3 and for our class on September 17th. So that's next Monday. So there will be some supplies that you need for next week for our live class. So we're going to be doing some tests on some rocks and minerals. So make sure that you look in the supplies list and bring some if you can. So when I click on that, you can see right here in our live class on September 17th, we will test some minerals. I want you to print this chart and bring it out. There's a PDF of it right there. And bring either 5 to 10 rocks or minerals to test. You can gather them from outside or you can buy a kit. So there's a link to Amazon and for a mineral kit and a rock kit. You don't have to buy those kits. They're about $10 each. You don't have to buy them, but class is a little more meaningful if you at least bring some rocks and a piece of ceramic tile and a nail to be able to test them. Okay, so bring those if you possibly can. But in any case, please make sure that you are always checking the supplies list a week or two in advance. All right, so let's take a look here now. Please remember when you write to me through Canvas inbox with a question, make sure you give me the name of the lesson, the question number you're asking about, and a lot of details. So I know I've said this before, but I'm getting a lot of having to write back and forth with students. It's happening quite a bit. So I just want to remind you, please, the more detail you can give me, the better. All right, this is really important. We talked about this last week, and some of you guys told me that you were going into grades to find your assignments. So I'm going to, again, show you what I mean here. If you go to the home page right here, there's all this information. Over here on the left, there's a thing that's called grades. Now, the problem is, if you're using this for your navigation to figure out what you need to do, you might skip some, and you might do some you don't need to do. For instance, a couple of you told me that you had already done ones that had delete as their title. Well, those weren't deleted yet. So you did something you didn't need to do. And at the same time, there will be some that are not listed in here. This is a fake student account. That's why I'm showing you this. It's got all this missing because it's just so I can see what things look like from a student's point of view. But what I want you to do instead, there are two ways that you should be finding your assignments. Number one, you can click on right here where it says modules. Close the course information one that you don't need for the day-to-day, and then just scroll your way down. If it'll tell you if they're done, if they're completed. And if you work your way down these lessons, then you won't miss anything. So in grades, the only ones that show up are the ones that have a point value. Well, there you can see there's a lot of ones here that don't have any point value at all, and they won't show up there. So you'll be missing some things if that's what you're doing. The other way that you can find your assignments from the home page, click right here where it says assignments. That takes you to the same page. Now, once again, if you go back to the home page, there's a calendar here too. I would like to take the calendar off, but AIM Academy has a policy that we like all our courses to look the same. You can click on the calendar. Again, though, may not be correct. Most of them will be listed here, but there may be some that are on here that are not on here that are due. So I recommend the way you find your assignments is to, sorry, I'm going to go back, is to go to, oh, here we go, is to go to right here where it says assignments and work your way down your list. Any questions about that? Okay, good. All right. Another new cool thing that we have now is called meeting summary. So once again, if I go back to our homepage right here, it says click above for class recordings. So if you ever miss a class, you miss one of these live classes and you want to watch the recording of it, if you click there, that's where they are. So you can click and watch it right here. You can even make it full screen and watch it right here. Or you can click this link here and go see it on YouTube. But that will give you the recording of the class that I made. Well, if you'll notice, starting last week, there's also a meeting summary. For the meeting summary, click here, and it opens up an AI-generated summary of our class. So this was the class on September 3rd for Earth Science, and you can read just a little summary that AI made about what it is that we covered. Now notice at the bottom, AI-generated content may be inaccurate or misleading. That's true. It does the best that it can, but it may get some things wrong. So if you see something in here that you're like, that doesn't sound right to me, it may not be. Check with me, and certainly don't just rely on something that's in here for any quiz or test that you have to do. All right, Valley, I'm not sure what you mean. What about your dashboard? Can you explain what you're asking?
You see, above the courses, there's this thing called dashboard. And if you click on it, it'll have like all your assignments.
Yeah, so I don't know that I can go to that from here. You mean over here? Is that what you mean over here on the right? Yeah.
Yeah,
Once
but
again,
for
that to-do list may not be accurate. I don't recommend doing that. I recommend that the only way you find your assignments is by clicking right here where it says assignments. That I don't know why Canvas gives you so many ways and why some of them are wrong. I can't do anything about Canvas. What I can tell you is this is the way to make sure you get all of your assignments and you don't do any extra. This is accurate where the other ways might not be. I'm not sure why. I wish it wasn't so, but that's what it is. Okay, any other questions? All right, so you did learn last week about longitude and latitude. I want to go into some more detail. They're pretty important concepts, so I want to cover them today. But first, of course, we have some jokes. So here's a little joke, a little cartoon. You better keep your distance. These guys are all over the map. Longitude and latitude all over the map. Of course they are. All right. So why don't impatient people like learning about longitude and latitude?
I can't have an assignment.
Why don't impatient people? Because they don't like long lines. All right. And A globe was walking down the street. It saw Central America crying on the curb. The globe asked, "Why are you crying?" Central America sobbed, "Because I will never get any snow." The globe replied, "Well, not with that latitude." Get it? Attitude, latitude. Okay. All right. If Mississippi bought Virginia a New Jersey, what would Della wear? Idaho, Alaska. I don't know. I'll ask her. All right. All right. What kind of maps do spiders make?
Okay.
What kind of maps do spiders make? They make web-based maps. All right. Remember last week how we did some of those questions to get acquainted? We're going to do a few more today. So using just 1 or 2 words or as few words as you can, type your answer into the chat box. Here's your first question. If you had to choose between only having a cell phone or a car for the rest of your life, which would you choose? Car, car, car. Oh, all of you guys are picking car. Look at that. Valet says cell phone. Henry says cell phone. Meredith. Aisha. Just get a flip phone? Yeah. All right. Anybody want to say why? Why would you pick a car? Meredith.
But what?
Why would you pick a car?
So you could drive to places,
Yeah.
but you could also get a cell phone to like call an Uber.
True.
Uber,
That's
yeah.
I hadn't thought of that. That's a way around. I love that workaround. Yeah, you could call an Uber, call a taxi, get a bus. True, true. Yeah. So why, those of you who said cell phone, why'd you pick cell phone? Valet.
Because you kind of use it for everything, and like it's pretty much the main way we communicate, and you can, like I said, call a taxi or an Uber.
Yeah. Yeah. Aisha.
Because if you got a cell phone, like you could call a car, and
Yeah.
then you can also do everything with that, like you can do with a car.
Yeah. That's true. You can do a lot. All right. How about this one? This question's that bottom one's out of order. So we're going to go to the top here. What's the weirdest food you've ever eaten? The weirdest food you've ever eaten? Fish. Fish is weird? Yeah, define weird. That's right. That's right. I don't know, whatever I guess you call weird. Alligator. Alligator's definitely a little bit odd. Shrimp pizza. I don't know how I feel about fish on pizza, even seafood like shrimp. Maybe. Maybe. Sea snails? Anybody? Alligator soup. Anybody ever eaten any insects? You can buy chocolate covered ants or chocolate covered grasshoppers. I had earthworm cake once. Maisie.
For Harry Potter, there's this chocolate covered frog that I ate.
Yeah. Yeah. Elena accidentally. Yeah, we all, the truth is we all eat insects accidentally. There's often insects deep inside the tiny ones inside the vegetables that we eat. So you may not know it, but you're eating them. All right, how about this question? What type of music do you listen to? What genre? Do any of you listen to music? Banda? Any? Leah likes any music. Piano music comes from my favorite shows. Yeah. Usually worship or just random cool songs. Country, pop. Karen Leon. I don't listen to music. Rap, particularly NF music, the music kind. Yeah. All right. Excellent. We have a lot of varied interests here. How about this question? What is your most treasured material possession? This is not a person or an animal. This would be a thing. Your most treasured material possession. Your pens. Those must be some nice pens, Aisha. Anybody else? My blanket. Oh, that you've had since a baby. A blanket, my Legos, trophies, drawings. Fun answers. All right, one more question. What is your earliest childhood memory? The earliest thing you remember from
That's
when you were
hard.
little. Asking my dad if it was Thursday. Ah. Was Thursday a special day? Somebody stole my ice cream in preschool. Oh, that's heartbreaking. Disney World. Yeah, that would make an impact, wouldn't it? Playing at a playground? School? When my sister pushed me off the swing and dumped sand on my face. Oh, Helena, that's terrible. A roller coaster, that's a fun one.
Are you done?
My earliest is the day my baby sister was born. That was a fun one. Sticking a straw up my nose. All right. Excellent, everybody. That's really fun. Thanks for playing along. All right, I came across a recording of a sound that I thought you might find interesting. This is the sound of a black hole. Pressure waves sent out by the black hole at its center cause ripples in the cluster's hot gas. The actual sound is one that humans cannot hear, a note 57 octaves below middle C. NASA amplified and mixed the noise to create this eerie sound. Sounds like a pretty scary movie, doesn't it? Yeah, low-key, kind of creepy. Yeah, so you know what a black hole is. We'll talk about black holes in the second part of our course when we leave Earth and go out into space. But black holes are, they're sucking in all the matter that's around them. So they're swallowing up everything that's in their area. It does kind of send shivers. I agree.
It's low key in two ways.
Yeah, you're right about that. Low key and low key. Excellent. All right, now let's talk about longitude and latitude. So in order to really understand longitude and latitude, we have to talk about graphs. So you read about longitude and latitude last week. It was in lesson 2.2. If you haven't gotten there yet, hopefully you'll still be able to understand what's happening. This is really an important concept though, when we're talking about the Earth. So I want to go over, review it or introduce it depending on where you are. So looking at a graph, this is what we would call a typical graph. And it's made up of these points right here that are connected by lines right here. You can see that we have some numbers across the bottom. We have some numbers on the left side. So this right here is called the x-axis that goes this way. And this is called the y-axis, goes that way. Now, the way that I remember the difference is I picture the letter Y with its long tail. I don't know why my pen does that. With its long tail that goes all the way down. That's the y-axis. If you can remember that's the y, you can remember that that one is an x. Now, in a typical graph, each of these points has two values. It has the x value that runs along this horizontal x-axis. Let me get my pointer back. Right here. This is the x-axis, so it has an x value. And it has a y value that runs along the vertical y-axis. Now, each of those points on that graph is expressed as an x and a y, and the x comes first. So here's an example. This one is 4,7. That's where that's found because it's 4 on the x and then 7 up on the y. So it would be 4,7. All right. There's another one. This one is 7,5. You go 7 over from the 0 on the x and then 5 up on the y. So it would be 7,5. Now, hopefully this isn't new. You guys probably have had this in a math class at some point, but if not, that's okay. You can learn it now. Now, we can also not, so this graph right here just has one big main center with the numbers here on the far left and on the bottom. Right here, though, this graph has the x-axis in the middle here and the y-axis in the middle here. And it's dividing this whole field into quadrants. So graphs can be divided into quadrants. This is quadrant 1, 2, 3, 4, however you number them. The x and y values, when you have 4 quadrants like this, are either positive, meaning above the line or to the right of the line, or negative, meaning below the line or to the left of the line, depending on the quadrant that we find them in. So let's apply this same idea here to longitude and latitude. Now on a map, these horizontal lines, the ones that run level with the horizon, that are flat and go this way, those are called lines of latitude. The vertical lines, the ones that go up and down on the map, are called lines of longitude. And the x-axis on a map is the equator. That's the one that runs this way, right there. That's the x-axis, that is the equator. The y-axis is called the prime meridian. That's the one that runs right up and down, and it runs through Greenwich, England. Now, we've also got this Tropic of Capricorn that would be in the south of the equator and Tropic of Cancer above the equator. We don't really need to worry too much about those. Now, one way that you can remember the difference between longitude and latitude is this cute little cartoon. We have latitude and long hair dude. So the latitude is the ladder. The lines like the rungs on a ladder. Long hair dude it goes up and down. His hair goes up and down. So longitude is going to be long hair dude. Longitude lines go up and down. They're long, like his long hair. Latitude, those are the lines of latitude that go this way. Just a funny way to kind of remember that. All right, so any location that is north of the equator, that would be up above where it's gray, where it's shaded, that is a north latitude. Okay, let's hold our conversation now to just science stuff, all right? Yeah, it's too distracting when you guys are talking about other things. Okay, so any location that is south of the equator is a south latitude, like is grayed out in the picture there. Any location that is west, that way, of the prime meridian is a west longitude, and any location that is east of the prime meridian is an east longitude. Now we can divide the whole Earth into 4 sections that we call 4 quadrants. We have the northeast right here, north and east. That's where all the latitudes are north, they're all above the equator, and all the longitudes are east. They're all east of the prime meridian. We can divide the Earth into southeast, into 4 quadrants where one of them is southeast. All the latitudes are south of the equator and all the longitudes are east of the prime meridian. Southwest, all the latitudes are south and the longitudes are west. And northwest, where all the latitudes are north and the longitudes are west. Remember, latitudes, if you could, again, this is one of those things, there's only 2. There's only longitude and latitude. If you can remember one of them, you know the other. If you think latitude, it's like climbing up a ladder. These lines that run this way are like a ladder, and you can climb from the bottom to the top up the latitude. All right. Now, look at the United States. Find us on that map. What latitude will every point in the United States have? Will we be north or will we be south? Every point in the United States.
North.
Yeah, north. Yep. And you got it, Henry. It's going to be northwest. So we're going to, every point is going to have a north latitude and a west longitude. So every point in the United States is all in the same quadrant. All right. Latitude. Latitude, that is latitude. Think of the ladder. That's the distance from the equator along that y-axis, the one that goes up and down. Remember, we have a y-axis. We draw this letter, this long y like that, and it goes like that. That's our y-axis. So latitude is going to be the distance from the equator along that y-axis. up like that. So those are going to be our latitudes. It is expressed in degrees, with the North Pole being 90 degrees north, and then the South Pole is 90 degrees south. Remember that the equator is 0. The equator is going to be 0 latitude. So what is the maximum possible latitude on Earth? What's the biggest latitude that you could have? Hint, you can't go farther than the poles. It's going to be 90. 90 degrees is the maximum. Yeah, sorry, I answered just a little before you guys. So 90 is the maximum. You could be all the way up at the North Pole at 90 degrees north, or you could be all the way at the South Pole at 90 degrees south, but there's no greater latitude on Earth or anywhere else really. All right, now let's talk about longitude, what longitude is. So latitude is this way. That means longitude is up and down. Longitude is the distance from the prime meridian right here at the up and down line along the x-axis. Yeah, you're right, Henry. We haven't gotten there yet, but it would be negative 90. 90 south would be negative 90. Yep, we'll talk about that in just a second. Good. So just like latitude, longitude is measured in degrees, and the prime meridian, just like the equator is 0, the prime meridian is 0, right there. If you go halfway around the world, you're going to reach the 180-degree longitude line. Now, understand, there aren't 2 of them, right? On the flat map, it looks that way, but on a globe, those wrap around and touch each other. That is the same line. So given that, what is the maximum possible longitude on Earth? Yep, 180. Good, Drake. It is 180 is the maximum possible longitude on Earth. All right, let's look at this now. Each box on this map is 15 degrees. So because it's really hard to see the little black ones, I drew the numbers in red right there, most of them, the ones that you need. So with that in mind, let's identify specific locations, which are the red dots. So remember, we always write our latitude first. Latitude is the ladder. That's from the equator up or down along the y-axis. All right, so what are the coordinates of location A right here? Anybody? Not 3060. Remember, we write latitude first. Yeah, it's going to be 60 degrees north because we're going up. So 15, 30, 45, 60. We're going up 60 degrees up. Remember, latitude is the distance from the equator. So we're going 60 degrees up, and then we're going 15, 30 degrees to the west. So it is going to be 60 north, 30 west. Notice we're not using pluses and minuses here yet. We're using north and west. So it is 60 north, 30 degrees west. What about B? What are the coordinates of location B? B is right here. Okay, you need more than just the number, and we're not using negatives yet. So you're real close, Drake, but we're not using the negatives yet. We're using south, north, south, east, and west. So you guys are all right with 15 and 105, but we have to say 15 and 105 what? Because remember, there are 4 15 105s on this map. We could have 15 105 up here, but we have to put in the north and the south. So I need you guys to make sure that you mute. Somebody's not muted. There we go. All right, I muted you. All right, so the coordinates of location B are 15 south. There's the 15 right there, and it is south of the equator. We always put latitude first. 15 south, and then what line is it on? The 105. The 105 is to the west of the prime meridian. So it's going to be 15 south, 105 west. What about location C? What are the coordinates of location C? Yep, 75, 75. But again, we need that north, south, east, or west. So it is going to be 75 south because we're going south of the equator, and it's going to be 75 east because we're going east of the prime meridian. Okay, 75 south, 75 east. This is in the southeast quadrant. Southeast quadrant. All right. But what about location D? Take a look at D. It's right in the middle of a box. What do we do now? What are we doing? It's right in the middle of a box. It's not right on a line like the other ones do. Yeah, we have to kind of fudge it a little bit. We take a guess. Now, if we had exact, accurate map right here, we wouldn't guess. But for our purposes, we could say something like 37 north because it's between 30 and 45. So it's probably going to be about 37 north and about 97 west because it's going to be between 90 and 105, somewhere in there, about the 97 range. So yeah, that's about right. About 37 north, 97 west. All right, so here's a couple things to remember about longitude and latitude. We always write latitude first, and it must always include either north or south to tell us whether it's north of the equator or south of the equator. Longitude is written next, and it includes E or W for east or west of the prime meridian. All the latitudes in the United States are north, and all our longitudes are west because we're in the northwest quadrant in the United States. Lines of longitude are not always the same distance apart. So lines of latitude are, let's look at the globe here. So the lines of latitude, those are the ones that run across. They're the same exact distance apart, but the ones of longitude are not the same distance apart. Where do you guys think they're the closest together? And they run up and down. Yeah, they're going to be real close together at the poles. In fact, they come almost to a point at the poles, and then they're going to be the widest at the equator. They are not always the same distance apart. It is greatest at the equator and least at the poles, and you can see that when you look at them on a globe. So take a look at Australia there. What longitude and latitude, not the numbers, but the north, south, east, west, what quadrant, in other words, is Australia in? Not southwest. Remember, west is going to be the other way. Yeah, it's going to be southeast. Every longitude and latitude in Australia is going to be south and east. What about Asia? Find Asia. What's every longitude or latitude and longitude going to be? Again, not west. It's going to be north and east. So when we're looking at a map like this, west is over here and east is over here. I always kind of remember because this, if we look at the United States, California over here is on the west coast and New York and Florida are on the east coast. So if you can remember that, no matter where you are, if you're in the United States, no matter where you are, you can remember which way's east this way and which way's west this way. Toward California is west, toward New York is east. All right, take a look at Greenland now. What quadrant is Greenland in? Northwest, there you go, northwest. Here you can really see how those lines of longitude, the long hair dude, remember long hanging down? You can really see how they come together at the poles. And they're real close up here, but they're really wide when you get down by the equator. Okay, so is it possible to walk all the way around the world, crossing all 360 degrees of longitude in less than a minute? Can you cross all the lines of longitude in less than a minute? You can. Yeah. If you stood at the North Pole or the South Pole, you could simply walk a little circle. If you walked a little circle around, you would cross all 360 degrees of longitude in less than a minute. What about the lines of latitude? Is it possible to cross all the lines of latitude in 1 minute? No, it is not. It is not. You would have to go all the way from the South Pole, all the way to the North Pole to cross all the lines of latitude. Remember, latitude is like a ladder. You'd have to go up all the rungs of the ladder And you certainly could not do that in just a minute. All right, so take a look at 30 degrees north. Is 30 degrees north a latitude or a longitude? 30 degrees north. Is that a latitude or a longitude? Remember, north, you're going above the equator. That's a latitude. You're climbing the ladder, going north. If you're going south, you're going down the ladder. You're going south. What about 30 degrees east? Is that a latitude or a longitude? If you're moving east, yep, that's a longitude. You got it. Going east or west is a longitude. All right, so one plane is flying around the world at 30 degrees north latitude and the other at 60 degrees north. Okay, so let's find 60 degrees and 30 degrees. One plane is flying around at 30 degrees north latitude, that's right here. And one plane is flying at 60 degrees north latitude. Which plane travels farther? Yep, the one that is going 30 at the 30 north. Yeah, because it has to go this whole distance, where this one only has to go this distance right here at all. What kind of vegetation would you find at high latitudes? Latitudes in the 60 to 90 range. Yeah, not much. Vegetation means plants, but you wouldn't find much. Yeah, you'd find a lot of ice, that's for sure. It is tundra there. Yeah, there would be some scrub. There'd be some plant life, but not much. Not much at all. All right. So we talked about, we've looked at maps here now. You saw flat maps and you've seen this globe and little drawing of a globe. It's really hard to make a flat map. Why do you think it might be hard to make a flat map? Isaac.
One, the video is going to show us, and two, correct?
Correct.
And two, it's because if you take a flat thing and put it down, it's going to warp part of it.
Yeah, it does. It's going to work. The orange, you're right, Valley. So if you did that experiment with the orange, you see how hard it is to flatten out a round object. And Isaac's right. We're going to watch this video to see why we have these distortions when we try to make a flat map.
You don't often see a world map like this, but it's one of the best ways to highlight the oceans. There's no perfect way to put a round planet on a flat map. Something is going to be distorted. Cartographers have peeled the globe in many different ways, and each has its own advantage. The famous Mercator projection from the 16th century was great for sea navigation, but Greenland looks bigger than Africa, even though Africa is 14 times larger. A German mathematician named Carl Mulvady created an elliptical projection. You can't use it for navigation, but it accurately compares land areas. Pull the oceans apart, and land areas lie even flatter on the page and are even more accurate in shape. For our map of the ocean floor, we used an interrupted Mulvady centered on the Pacific and divided the land rather than the seas. The three main oceans are shown in their entirety with the least distortion possible.
Yeah, it kind of gives you an idea of how hard it is to make that kind of a flat map of a round object. So now take a look at this map. This, of course, is the United States. Anybody remember what the name of this kind of projection is? There's a map projection that we're looking at here. This is called conic. So remember, in the Mercator, all the lines form squares, and with equal area, the map itself will look like an oval. Take a look, though, at the states here. Take a look at some of the borders of the states. Find one that is like a rectangle. So right here we have Colorado. Colorado is a rectangle. Wyoming is a rectangle right there. So they are completely defined by lines of latitude and longitude, right? That's what gave them their square borders. But take a look at Idaho. Anybody see Idaho? It's right here. Yeah, you're right. Utah is with some cut out. Utah is a little bit, is very right here. Utah is also with lines of latitude and longitude, but part of Wyoming goes there. But look at Idaho. So what features on the border make you think that this border was drawn along lines of latitude? What do you see that might have been a line of latitude or longitude? In other words, are there any straight lines?
The bottom line.
Yeah, the bottom and
Part
the
of the
one on the
right.
far right. Yep, those are drawn along lines of longitude and latitude. What other kinds of features might form a natural boundary? What do you think might be responsible for this curvy, wavy line on the east side of Idaho?
A river?
Yeah, a river. Very good. So notice that some of our borders are straight, but they're not along the lines of longitude or latitude. Because right here, there's a straight border, but that's not exactly on this line of longitude or latitude, but it is on one. For between 100 and 110, you'd have 109, 108, 7, 6, like that. Now, take a look at this one right here. Do you see any rivers that form boundaries? Sophie?
There's a kind of one that's near Texas and the Mississippi.
So right in here? Yep.
Yeah.
This would be between Louisiana, that's this one right here, and Mississippi right here.
There are at
that-
least 5.
Yeah, there's quite a few actually. Look at the Mississippi. The Mississippi forms borders all the way. It's the dividing line between Illinois and a couple of other, all the way up here. The Rio Grande. Well, the Rio Grande is a border between Mexico and the United States. It doesn't really divide a state in the United States. But part of the Colorado River does here and here. Certainly, let's see here, where else? The Red River forms the northern part of Texas. Savannah, yep, right there. Savannah is between Georgia and South Carolina. That makes that boundary. Yep, so that's part of the way we got some of the states that we do. We got why is this part right here Texas and this part right here is Oklahoma? Well, it's because of the Red River. It's the dividing line. Drake.
The Columbia River in the top.
Yep,
corner.
Columbia could be. Yep. All right, so look at this now. When I overlay that first picture that showed the states on top of the one with the lines. So we had this one here and then this one here. If I put in the names of the states, then you can really see it. You can really see between Oklahoma and Texas is the Red River, and between Mississippi and Louisiana, Mississippi and Arkansas, Illinois and Missouri, Illinois and Iowa, Wisconsin and Minnesota. You can see those rivers make borders between them. So that's how we got a lot of the borders that we have. And that's also how other countries get some of the borders that they have. All right, let's talk a little bit about GPS. What does that stand for? Anybody know what GPS? You probably all have one.
Something navigation, something.
Global.
Aisha.
Global positioning system.
Global positioning system. There you go, right there. So a lot of cars and a lot of phones have built-in GPS. And what do you use it for? What do you use a GPS that's built into your phone or your car for? Arhan. Not hearing you, Arhan.
Track where you are.
Yeah, exactly. To really determine where you are. If it's in a car, it's to determine your car's location. If it's in your phone, it'll determine your location. So think about the activities that people do where knowing their exact location is important. What about driving? That's important, knowing exactly where you are. Flying a plane. Can you imagine trying to fly a plane without knowing exactly where you were? Even things like boating and hiking and biking, those might help. Even dog collars. Did you guys know dog collars? Many have GPS on them. If I had a dog that ran away a lot, I would have a collar that had GPS on it. But look at where they have to be. GPS these satellites have to be out in space in order for GPS to work. That's kind of expensive. So there's a cost to putting satellites into space and then maintaining those satellites. So I want to show you a video that shows how GPS works.
GPS and a quest for pizza. It's Friday night and you want some pizza, fast. But somebody is going to have to pick that pizza up. If that means they need to know how to get to the closest pizzeria. In this modern world, that's no problem. Just plug pizza into a smartphone and it tells you exactly how to get there. But how exactly does the phone know where you are? Something called a global positioning system, or GPS, tells you that's how. When your phone tells you where you are, it may actually be listening to signals from satellites high up in space. There are over 30 satellites used for GPS, orbiting over 16,000 miles above the Earth. Your phone just needs to figure out how far away you are from some of them. If your phone knows how far away it is from 4 satellites, then there is only one place on Earth you can be. Your phone, or any device with a GPS, is programmed to know where all the satellites are at any given time. The phone uses that information, along with the amount of time the signal took to reach it, to figure out how far away the satellites are. By doing that, it computes its location. So when you search for the nearest pizza place in your smartphone, this is what your phone is thinking. What satellites are talking to me right now? Hey there, satellites. I know you guys. And I know where you are in the sky right now, too. Let me listen to your signal to figure out how far away I am from each of you. Oh, I must be right here. There's no other place that is the right distance away from each of you. Okay, let me check the internet to see what pizza places are near me. And all that happens in an instant. Good thing, too. You're only getting hungrier.
All right. Any questions about GPS? So somebody said a couple minutes ago, I'm lost without it. Yeah, Valet, I'm lost without it. Henry said too. Yeah, that is one problem. We get dependent on some of our technology, don't we? I remember when the very first thing that I used to do when I moved to a new neighborhood was learn the roads. We don't do that anymore. We just turn on our GPSs and they take us where we want to go. So in some ways, might not be the best thing. All right, we're going to do a Kahoot now. If you guys want to get out your phones or your tablets. Did we do a Kahoot last week? I can't remember if we did one together or not. No, I don't think we have yet. We'll use Kahoot. We'll use Kahoot from time to time. So Kahoot is an online kind of a quiz game. So the way you play it, you need to either have a phone or a tablet, or you can just open a new window with your computer. So you do that by clicking this little plus right there, and it'll take you to a new window. And then type into the top www.kahoot.it. And it'll go, well, I did IG. .it. There we go. Nope. www.kahoot.it. There you go. And it'll take you right here where you put in the game pin. So your game pin for this Kahoot is 578495. I will type it into the chat box. So if you want to copy and paste it, you can. 5784953. And I will sometimes have Kahoots for if we run, we finish the lesson a little bit early if there's time. Most of our lessons will go right up until the very last minute, but if there's time, we'll do a Kahoot. All right, we don't have a lot of time to wait, so join quickly, or you can join afterwards by this code right here will always be at the bottom, so you can read it. All right, so I'm going to go ahead and begin now. 5, 4, 3, 2, 1. Here we go. All right, so this will show you the question and then some possible answers. Here's the question. Lines of what measure how far from the equator a place is? Latitude, longitude, equality, or meridian? Lines of what? Try to answer as quickly as you can. We'll get farther. It is latitude. Remember, latitude is the ladder that you climb. You start at the equator and climb up farther from the equator. That is a line of latitude. All right, next question. Lines of what run all the way down? Long lines from the North Pole to the South Pole. There are long lines. Lines of... Hopefully everybody will get this one. Lines of longitude. Excellent, 100%. All right, we're going to move fast through this. The invisible line at 0 degrees latitude is what? Date line, prime meridian, divider line, or equator? What is the invisible one at 0 latitude? Think ladder. Henry.
What's our... Okay, I just got to this place. What's our pin?
The pin is right down here at the bottom. I typed it into the chat box too.
Yeah, I can't...
578.
Wait, okay, sorry.
That's okay. I got to keep going though, Henry, because we only have like 2 minutes left.
Okay, sorry.
That's okay. The code is 578-4953.
Okay, thanks.
The invisible line at 0 longitude is, remember, long. What's the long one? Up and down from the North Pole to the South Pole. What's that called? Equator, date line, prime meridian. That's the prime meridian. The equator is the 0 at latitude. All right, I will destroy is staying in the lead. Wonder who that is. Lines of longitude are also called what? Longitude, up and down. What's the main one called? The one that's 0 is called the prime of this.
What is my old username? It just stayed in.
Oh, that's okay. That's okay. They're
clicked.
called meridians.
I accidentally clicked, but I still got it correct.
All right, the bomb moves into the lead with Meredith in second place. 1/2 of the Earth is called a half. What do we call half? You had this in one of your lessons the first week, I believe. Half. 1/2 is called a hemisphere. Hemisphere. All right, probably got time for about 3 more. Lines of latitude run north and south or east and west. Remember latitude. What do you do to climb the ladder? How do those lines run? Those lines run east and west. Remember the latitude. You stand at the equator and you climb the ladder. So the lines run this way. They run from east to west. Okay. Lines of longitude then run which way?
Misclicked again.
Oh, I know that happens. It's frustrating. Try to answer quickly, everybody. We have to count down. It takes a long time. So those run north to south. Lines of longitude, they're long. They hang down. Remember the long hair dude? So they run north to south. Valley's in the lead. The prime meridian is a line of longitude that separates the Earth into which 2 hemispheres? North and south, east and west. Remember what the prime meridian is. It separates into east and west. All right, the equator is a latitude line that separates the Earth into which 2 hemispheres? North and south, east and west. It is north and south. Very good. All right, we'll have time for one more question. Valley's in the lead, Meredith's in second. Lines of latitude and longitude are measured in Celsius, degrees, sections, or time. They're measured in degrees. Excellent. All right, that went so fast. Let's do one more. Locations are labeled as longitude and latitude points. What are these points called? Dots, placeholders, coordinates, or plot? They are called coordinates. All right, I'm gonna have to end the game. So let's see how we are
Can
doing
we
here.
finish it?
In third place, we have Halon Leona. Meredith is in second, and in first place we have Ballet. All right, excellent. Well done, everyone. Hopefully that was a good little review of longitude and latitude. When you're thinking about latitude, think about standing on the equator and climbing the ladder up or climbing the ladder down. If you can remember what latitude is, climbing a ladder, then you can remember what longitude is. It's the opposite. It's the ones that go back and forth this way. All right. Anybody have any questions? All right. Have a wonderful day. I will see you next time.
All right. Thank you. Bye.
you.
Bye.